everyone. So last time we talked a little bit about inheritance. We're going to talk more about inheritance today, and we're going to talk about other ways we can implement inheritance other than just subclasses and having that direct parent-child relationship. So as a review, let's go over what abstraction is. Abstraction is the segregation of implementation and the details from the usage of that implementation. It's heavily intertwined with encapsulation, and it helps us to be dry, which stands for don't repeat yourself. This is really important in OOP. This is our ultimate goal, is to not repeat our code and allow us to reuse as much code as possible. So let's take a look at an example that you should all be very familiar with, regardless of your programming background. What is an int? What is it? What do we do with it? How do we use it? And why does it exist? So if we take a look at each of these, what is an integer? Well, ints are really just bits. They're little pieces of information down at the binary level, represented with zeros and ones. And when we do things with ints, we're just messing with these bits. We're doing operations over these to change what they represent. But we don't see any of this. This is abstraction. This is us abstracting out the bit underlying layer, right? And to something that we're more familiar with, which is an integer. It's something that we see in everyday life, something that we're familiar with from our high school math courses. It's just a number. Whereas if we were to actually work with the bits directly, it'd be a lot harder for us to complete simple mathematical equations. So there's two types of abstraction. The first is control abstraction, which is about subroutines and control flow, and data abstraction, which is abstraction of the access to that data and manipulation of that data. So with control abstraction, what operations do we regularly use that are abstracted? So we regularly use things such as addition, multiplication, subtraction, division, loops and switch cases, and if statements, which help us to control our program and do simple subroutines that are really common operations in anything that we're going to program. Data abstraction is the separation of the concept from the implementation, and that's more of what we're going to be focusing on. So data abstraction, a simple abstraction, would be something like this. It should be very familiar to you. It's just a diagram of the animal kingdom, basically. So we have the animal kingdom at the top. It's a nice parent in this case. We have two children, vertebrates and invertebrates. And then we have reptiles and mammals under vertebrates and insects and shellfish under invertebrates. All right, so this is just a simple little example of abstraction. But what are some of the methods and properties that can actually be abstracted out of this? What are things that all of these creatures do? Let's go back for a minute. So if you look at all these, what do they all have in common? And then if you were to actually implement them, what would they actually have that's different? Where should each of these methods or data values be stored? So if we go ahead and look at my next slide here, we'll see that they all need to eat. All animals need to eat. They're all going to die, so we need a way to handle that process. And they need to drink, they need to consume water, and they need to be able to move. So in our particular example, that's what we need in order to actually implement these things. And they can probably all be, like, these can be initially defined at that top level and then be more specified as we go through the rest of that tree. So as we get to shellfish, for example, that move method is probably not going to have a whole lot in it. It's probably going to be relatively empty since shellfish, some shellfish anyway, don't move a whole lot. Now, other things we might need is some data. So we need the number of legs something has, the average life expectancy, and its actual age so that we know how close this particular creature might be to dying. So how would we do this? How would we actually implement this? What kind of things are we going to look at when we do this? What does this look like in Java specifically? So this is simple class inheritance. So this is what we talked about in the previous video, okay? So there's a link here, and I'm going to share these slides with you on iLearn, so you'll be able to get access to all the links. There's a few in here. A normal class for animal, that's the parent class, and then we have another child class for something like animal, or sorry, for something like mammal that needs to extend the animal parent class. And again, there's a link here with an example to some of that code. But when are we ever going to use the animal parent class outside of using it for purposes of inheritance? Are we ever going to just create an animal that doesn't belong to one of these subcategories? That seems like a little bit of extraneous information. Like, why do we even need it? So we probably don't. We probably don't need an actually implemented animal class. And there's a better way, and those two things are abstract classes and interfaces. So with an abstract class, we're going to use the keyword abstract and then the keyword extends, just like we would in the case of doing a direct parent-child relationship with subclasses. So an abstract class can contain properties, data members, abstract methods, meaning that we have methods that don't have a definition. We have complete methods, so methods that are completely defined just like we would in a normal class. They can contain access modifiers such as private, public, protected, and default. And they can contain complete methods that are static as well. But the non-complete methods, the abstract methods, cannot be static. Also, it continues to support that single inheritance that we're used to seeing with the inheritance that I mentioned in the previous video. So if we take a look at an example here, we have a shape which has the abstract definition for a method, the abstract signature for a method, draw. And then we have a rectangle which extends shape, and when it draws, in this case, it's just going to print out a simple line to the command line. But you can see how this is useful because we're never actually going to need something that is a shape in and of itself. We want things that are shapes, but a generic shape isn't very useful. What does a generic shape even mean? But we know what a rectangle means. So we want a rectangle and we want it to belong to this classification of a shape. But again, we're never going to directly implement anything out of shape itself. Now interfaces are a little bit different. It uses the keyword interface and the keyword implements. And we're going to go over an example of what that looks like in a minute. And there's no data members or properties. There's no constructors. You can have only incomplete methods. Everything is always public and nothing can be static. All right. But what's nice about interfaces is that we can have multiple inheritances. So we can have multiple parents if we use this interface method. And let's take a look at an example of what it would be like. So if we had that animal, all right, if we had that animal class again, and we had it as an interface, we would define it as interface animal, and then we have two public methods in which we have, we want all of our animals to define. Now, in addition to that, we have the public class mammal, and it implements the animal interface, all right? So keep in mind, interfaces, implements, everything else has an extends, all right? However, we have to define the methods that are explicitly stated in that interface, all right? So when do we choose to use what? When do we choose an abstract class, a direct parent relationship, or an interface over anything or over any of the other options, right? So for an abstract class, this is when you need some default implementation. You want to make sure that not everything is public, and some data properties need to be private, but also shared between all the different types of subclasses you're going to have out of it. So like, for example, this is probably better for the animal case because everything's probably going to need an age and a number of legs and those kind of things, rather than using the interface like we did in the example. And an interface is more about a contract. It's more about setting up an agreement of, yes, I will have these methods that other people can use so that they can interact with me. It's not really about the data or the properties that are in the class. And if you're going to do a direct relationship like we talked about in the previous video, you want to make sure that there's a reason for you to instantiate that parent class. Like it's not just existing for the sake of the inheritance, it's existing because it's worth something on its own. You're going to find that in Java, you're probably going to want to use an abstract class or an interface more than a direct parent-to-child relationship. So now that we're done going over the differences between abstract, classes, and interfaces, I want you all to go ahead and design a sporting event management system that includes at least 3 sports. And try to use different types of inheritance. Use abstract classes and interfaces to help design the system and make sure that it is a robust system. If you want, you can message me in our course Teams, and I will give you feedback on your design and help you to identify what is good and bad about your design. Now, you don't actually have to implement anything. That's not what I'm telling you to do here. I'm just asking that you design it. You denote what's going to be an abstract, what's going to be an interface, what kind of things are going to be included. And we'll talk a little bit more about how to formally do that with something called UML later on in the semester.